Hello, my name is Kays, and welcome to another episode of Kays Labs. So what did the cat drag in this time? Well, it's none other than the Korg Poly 61. The Poly 61 was introduced around 1982-ish, and this was like right at the cusp, right before MIDI was becoming a thing. So the original version of the Poly 61 does not have any MIDI. And then about like 6 months to a year later, Korg released a variant of the Poly 61 called the Poly 61M, in which they added MIDI. Now this unit does not have MIDI, this is like the original, but it does have like a bunch of kind of like weird issues going on that I'm gonna show you in just a second. So stick around and let's find out what's wrong with this Poly 61 and if we can fix it. What did a cat drag in this time? Well, not quite a cat, or I suppose it could be a cat. This is an actual client. This is somebody who's got a Korg Poly 61, and they said that there's some stuff that's not quite working, and they wanted me to take a look at it. So, a lot of people really love the Korg Poly 61. This is not the M. Poly 61M has MIDI built into it. This does not have MIDI, so you just kind of like sort of play it live, I suppose. So here's the interesting thing. If you go and play a few chords, like, you know, around the middle C area, they'd be like, okay, I mean, it sounds fine. That's kind of supposed to be the way it sounds, right? Well, but now, if we start playing some of the other octaves here, let me go through the entire keyboard. So there's definitely weird shit going on. Stuff like that does not sound right. So it's interesting because, like, you know, right around like this middle octave, things start, you know, sounding pretty well, but as you move further away, you know, things just kind of get progressively weirder. I already tested all the buttons, everything kind of works. There's some aesthetic issues. I mean, Korg used this kind of cheap laminate stuff, so I mean, throughout the years, you know, like this stuff kind of starts peeling off and just, I wish they would have just kind of used solid wood or something like that, but I guess they were trying to save some money. What else? The little joystick is a little bent. I don't know if you can tell. But I mean, by and far, like the main issue is this weirdness, this... Yeah, gotta fix that. So let's open it up and take a look inside and just kind of get a sense, the lay of the land, just so that I can kind of sort of see what needs to be done. Okay, so just popped off 4 screws from the top panel and it flips open and it's got this little kind of hinge system, so that's kind of nice. Much better than the DW series. So right off the bat, there's like one big massive red flag here, which is this guy right here. So this is the, I don't know if this is the original battery, but this is one of those batteries that has a tendency to leak. If we kind of look at the backside, it's already started leaking. Now, thankfully, it hasn't really done much damage to the circuit board below. I'm gonna have to take a closer look, but this guy definitely needs to go. I'm gonna replace it with one of those portable little flat batteries to retain the preset memory. Aside from that, I mean, everything looks reasonably clean, but what I have spotted is a little bit of leakage from some of these small little capacitors. I can't really show you on camera. There's just like a little bit of kind of leakage. If you look very carefully, it's just hard to see on camera. So you just kind of have to take my word for it. Other than that, what I think I want to do is remove the keyboard and clean out the contacts, because there's definitely like some keys that were like acting a little funky and not triggering. So I want to take care of that first. I want to replace the battery. I want to replace the leaky capacitors throughout. I measured the voltage already. I mean, everything looks pretty decent, but I don't know. I mean, there's just like a handful of capacitors here in the power supply. I might just be tempted to just kind of recap the whole thing. I know what I've said in the past, that people get a little too recap crazy with this kind of stuff. But in this case, I do have enough little, warnings, visual warnings around the keyboard to think that maybe recapping some of this stuff is not such a bad idea. I looked at the keys, the different voices. This is like the main voice board. It's like 1, 2, 3, 4, 5, 6 different voices. And there's like little LEDs that, let me see here. You might be able to see if I turn off the lights. Let's see. So I don't know if you're able to see those LEDs, but they kind of light up whenever each voice sounds, right? And some people might say, oh, probably what's happening here with this kind of stuff is because one of the voices or two of the voices are screwed up. But not necessarily, because when I was kind of sort of taking a closer look at this thing, I realized that the voices individually throughout the 5 octaves of the keyboard can sound just fine. It's just certain keys kind of get wonky. So I kind of suspect that it's not necessarily the voices that are failing. I kind of suspect it might be something else. Perhaps this board right here, which is basically taking the information from the main keyboard, and I think it's using like some multiplexers to split it out and send it to each individual voices. So I kind of suspect maybe there's something going on there that might be causing this weirdness. But one thing at a time. I'm gonna start by probably like kind of choices. I'm gonna start by maybe like removing the battery and taking care of that stuff first, and that's like a bit of a clicking time bomb that I don't need. And then I'll move on to replacing some of the capacitors and then move on from there. All right, so the first thing I'm doing is just kind of removing all the connectors. As always, I always say, like, take photos, take photos, take photos. You will never regret having photos of the before when you go and put everything back together, because trust me, it's so easy to get these things mixed up. Some of them do have like some numbers on it, which is nice, but not all of them. So anyway, just something to keep in mind. As I take a closer look at what is the CPU board, which is what this guy is doing, I'm seeing like some kind of funkiness. Let me see if I can, let's try this. So for instance, there's some, like this resistor right here just looks, here, let me point it out to you. So this guy right here, this resistor right there, is looking a little rough to me. I'm gonna take a closer look around here. I mean, there's like some other kind of funkiness, like there's this, I don't know if you can see on this trace, that it's not in great shape. I have to wonder if this is not the original battery. Maybe the original battery did leak, did cause some damage, and they kind of fixed it as much as possible. I mean, other than that, there's like some kind of bodge wires here. I think those are kind of like factory little alterations. This is obviously like the first revision of the Poly 61. What else? There's this weird ribbon connector. I'm gonna try to leave this in place if I can. I just don't want to deal with like this kind of weird type of connector, like unplugging it and plugging back in. It's just, if I don't have to deal with it, if I can kind of like literally I just kind of unscrew this and kind of flip it over and do my desoldering and whatever else I need to do, it's going to be a little bit easier for me. So anyway, that's what I'm going to do. I'm going to start unscrewing things and then get rid of this battery and start taking another look at the rest of the components just to see what I'm dealing with. So I'll show you real quick. I mean, there's a lot of things that Korg will do that, in my opinion, is kind of questionable. But like the circuit boards are actually kind of jammed inside this thing. So I just kind of remove the screws here. I'm just going to gently pry it off so I can kind of free up the circuit board underneath. The other thing I'm just really not crazy about that Korg has done is just kind of put this weird metallic, I guess like RF shield under there. And while it normally doesn't cause problem, there's like enough clearance. It's not unusual for like the wood beneath with age to warp and then make some kind of short contact underneath. So that's not great either. Other than that, like, I don't know, I just kind of spotted like this kind of weird discoloration on some of these pins. I'm gonna try to kind of clean up things as much as possible, but let's get the battery first. I'm just gonna use the handy solder sucker instead of the solder gun for this, for right now, but I'll probably use the solder gun for the capacitors that I need to replace. But basically this 1, 2, 3 pins is the battery, so I need to kind of, there's like two that are attached to the negative side and one on the positive side, so I just need to get rid of those. Overall, like the underside of the board looks reasonably clean, I would say. So I mean, there's definitely like a little bit of kind of funkiness on the battery side, but I don't think, as I said, I kind of suspect maybe like that's a battery that's already been replaced once before. So anyway, let's just get on with the business of desoldering the battery, and that's a good starting point, I think. I just really dislike how Korg bent the pins inward, and now I'm gonna have to like try to figure out a way to either cut them off or bend them backwards without damaging the traces, which is always just not fun. I think I'm just gonna cut the pins from the other side and then slip those guys out. Alright, so definitely not the most fun I've ever had with a soldering iron to get like these little bent pins out. I had to use like a little razor blade to kind of gently pry them open and then kind of slowly slip them out. But that part is done, the removal of the old battery, and this side looks okay. Sorry about the focus, but I think I'm gonna have to clean it up. But I do want to take a look at this other resistor right here. It just looks a little funky to me, so we're gonna replace it. Yeah, so I'm just gonna take it out and replace it, just to be on the safe side. This thing is like burnt and cracked. I think this guy's fried. Something happened, but I think it's a good idea that I took it out, because this thing definitely isn't working. All right, so looking at the Korg schematic, this is a little confusing because this is R201 is what I just took out, and right here it says 47K, but then it's scratched off and it says 1K. Same thing for R26 and R25. I guess the engineers realized that they didn't need those values of 47K, and instead, or maybe it's like 4.7K, I don't know what it is, but it's really, I guess, supposed to be 1K. And I confirmed that by also looking at the color coding of the capacitor, which is brown, black, red, gold, from what I can tell, and that is indeed saying 1K. Before I start putting you know, the wires for the removable battery and the new resistor, I want to do some cleanup here and kind of check the continuity on some of these traces. I mean, this section is looking like really rough to me, so I just want to like clean it out, make sure that everything is going to where it's supposed to before starting to solder new stuff in. So I have these two wires that are connected to, I guess I was wrong, it's like the two positive little pins and then one negative over here that correspond to black and red wires here, which I will hook up to a little battery holder a little bit later on. But at least this stuff is done. I replaced the resistors. Some of you might have seen in my other videos for the DW6000 and the 8000, I like to come in from the underneath as opposed to having like this kind of wires kind of jumping over here, which is always kind of messy. I much prefer to kind of have them come in from underneath the board. And just to be on the safe side, I put like some electrical tape underneath here to kind of cover a little bit of this you know, this material that could be conductive, just to be extra safe. I don't think I need it. I do have enough clearance over there, but just in case, I put a little bit of electrical tape on the underside here. All right, so another place that I want to take a look is this board, which is the 477 board, which is really the one that controls where like the volume controls and the tuning and that kind of stuff is. So as I was taking a look around, I just wanted to like kind of double check and triple check all of the circuit boards, and I spotted something really funky going on here. So let me see if I can kind of show it to you. I don't know if you can see right there on that capacitor. See how the leg is all green? I mean, that's not good. That's kind of like a discharge. You can kind of see it here on a couple of these other capacitors right here. So these guys are kind of like in the early stages of leaking. My guess is that if I measure them, they're probably okay. But what it's telling me is that they're starting to kind of break down a little bit, and they're starting to kind of have a little bit of leakage. So I want to change, just to be on the safe side, I'm going to change every single one of these electrolytic capacitors, all the blue ones that you see right here. And on the board underneath, the one I was just kind of working to replace the battery, this guy, I double checked and triple checked as much as possible the capacitors, and they do look okay on this board. I even replaced one just to check the value, and it was fine. So I'm not going to worry too much about the capacitors here. So this capacitor, this is like a pretty standard electrolytic capacitor, except it's horizontal or axial. But I mean, other than that, it's polarized. It's got like a positive side and a negative side. And unfortunately, I don't have any axial capacitors on hand, but I do want to replace them because it's looking pretty nasty. So I'm just going to use this vertical capacitor, and I'm just going to put it, obviously, with the correct polarization, and then I'm just going to kind of bend it sideways so it doesn't take up as much vertical space, and it will be fine for what I need to do here. Before I put this guy back in, I just want to like kind of talk about a small little detail that I think it's important. So see, there's like these little plus markings on the circuit board that are indicating the correct polarity which the capacitor should be installed in. Well, here's a tip. Before you remove the old ones, verify that indeed this is true, because sometimes the silkscreen markings on the circuit board are not necessarily correct. So always double check with the existing electrolytic capacitor before you take it out, just to confirm that indeed the markings are correct. And if they're not, make sure you make a note, because otherwise you're going to get yourself in some serious trouble. Having replaced all the bad electrolytic capacitors on this PCB and the resistor over there, I want to take a look at the power supply. I was thinking about like possibly recapping the power supply. However, before I do that, I just want to take a look at what's coming out, because there is this golden rule in repairing vintage synths, which is if it ain't broke, don't fix it. If it doesn't look like it's about to fail, don't leave it alone. So let's take a look. So I have my voltmeter here. So let's go into the first pin, and this is supposed to be negative 15 voltage, and it's pretty much spot on, negative 15.05. I mean, it's really good, honestly. The third pin should be the negative, or the 5-volt supply. This is also looking really good, 4.99, geez. And then the last one is supposed to be the 15-volt rail. And once again, this is looking pretty damn good, 14.973. I mean, that's close. Yeah, I mean, these are good voltages. They really are. So with that in mind, I'm kind of inclined to think that the power supply is just fine and doesn't really need to be messed with some more. Where are we at? Battery's taken care of, bad electrolytic capacitor is taken care of, but we still have the underlying issue with the notes being weird. I reloaded the memory just to make sure that everything is at least as good as it was when we first started. So yeah, we are back to the same issue, right? Which is central octave seems to be okay, but like as we get like further away, things get progressively weirder. I'm still not inclined to think that it's one of the voices. I think that there's something else going on here, and I have my suspicions on that board right there. However, before I tackle that, what I'm going to do is I'm going to take out the keyboard and I'm going to clean the contacts, because there's definitely a couple of keys that are kind of weird. And just to kind of rule that part out, I'm also going to take a look at the diodes and just kind of make sure that there's nothing funky going on with the keyboard that might be causing this. I don't think there is, aside from the bad contacts, but as I said, it's just like a process of elimination. So let's do that first. Poly 61 keyboard by itself. It's pretty standard, non-touch sensitive, no aftertouch type of keyboard. As a matter of fact, it's probably the same one as they used in the DW6000, I think. But what I want to do is, flipping it over, I want to remove all these screws and take out this sensor board right here, so I can take a look at the sensors, make sure there's no dirt and other stuff, kind of carefully clean it, maybe with a little bit of alcohol, and then just kind of put it back and see where we're at. So what I'm going to do is just kind of like separate these groups of sensors, and then with a little bit of alcohol, just kind of gently clean all of these contacts, and same thing on the little rubber stopper things, and then kind of put them back, and that hopefully should take care of any intermittent contact. Before I put everything back together, I always like to just kind of connect the sensor board to the keyboard, make sure that all the sensors are working. I did make a note on this funky one that wasn't working before. And now everything is working fine. So at least the sensors are working. I mean, the problem is still present, but I'm going to put the sensor board back into the keyboard, and that way this portion of it should be done. Now is not a bad time to just kind of do a visual inspections for all the little plastic tabs, make sure nothing is snapped off, and taking a look inside here as well. You know, this is just good practice. You know, that way I know that if there's any other issues with this keyboard, it's not going to be because of some of the plastic that is broken off. So keeping on going, we move back to this board. It's kind of a KLM 478A, which I think is the source of our issues. Now this board, what it's doing is that it's helping to kind of calibrate, I'm assuming, how the voltages are being assigned across the keyboard, so you can kind of get like a proper tuning around. I think it's also having something to do with like just maintaining like an even loudness across the keyboard. So I tried calibrating it following Korg's instructions, and I couldn't get like a reasonably happy result. So there was obviously like something that I was kind of suspecting that might be an issue. I resocketed the 3 op amps, 1, 2, 3, and then this guy, which is the 4051, which is a multiplexer, demultiplexer chip, which are known to fail. These guys have like a high failure rate, so I opted to replace that. And I was still having like problems calibrating the keyboard. And I started looking around to see if there was any other suspects around here. And unfortunately, I can't really show you like the before. I'm going to try to post a photo, but there is another 4051 right here, okay? And this guy was looking really, really awful. Let me see here. I'll try to dig up the part that I removed. You can kind of see there was like a lot of corrosion on the legs. Hopefully you can kind of get a good idea of what I removed. And replaced this guy as well, and then went back and tried the calibration routine once again. And this time it was a lot closer. It was much, much better than what I had been able to do previously. So I'm going to show you a little bit what's involved. The unit is already calibrated, so I don't want to like mess around with it too much. But just to give you an idea of the basics of what Korg wants you to do as far as calibrating this particular circuit board, I will say this. The instructions are pretty awful, and I think that unfortunately the Poly 61, in my opinion, has one of the worst service manuals that Korg ever published. It's just not very clear, and there's like just a lot of inconsistencies around. But let's just kind of go through the process so at least you get an idea of generally what is involved in the calibration. As I said, I already calibrated, everything is working fine, but I'm just going to show you a little bit what Korg says that you need to do in the service manual. So the first thing that they ask is that you set to program 12. Great. And the next thing that they want you to do, I'm going to try to keep the volume a little bit low because we don't really need to hear too much about it. But the next thing that they want you to do is to basically engage what is a monophonic mode, so that you're triggering all the voices with just one button. And the way you do that is you push the hold button, you press the same key like 6 times. It can be like any key. Let's do like A, 2, 3, 4, 5, 6. And then what you do is you push the chord memory. Okay, you push the chord memory after hold is engaged and you press the key 6 times. And now it's basically playing in monophonic mode. So if we open it up, you probably won't be able to see this very clearly, but there are little LEDs here at the bottom of the voice board, and they're all lighting up when I just press one key. So basically Korg is saying like, make sure that like all of the voices are being triggered by one key. Okay, great. So the next thing that they want you to do is to check a specific voltage. And once again, sorry if I just don't have enough hands. And I also don't have enough cameras. Soon, you know, subscribe and like, and maybe I'll be able to start adding more stuff. So basically they want me to check a voltage. There's like a little test point right here that's on this side of the board, right next to this ribbon cable right here. So I'm gonna stick one probe in the ground, which is this blue cable right here. I can kind of like verify it that if I plug it in here, it's giving me the 14.96 reading. And what they want me to do is just kind of probe this little test point and get a voltage from there. And I do. And when I do, it's reading 09.964, which is really, really great. I mean, they specify a range between 9.8 to 10.20 volts, and I would say we're like pretty damn spot on. I mean, I have to say it's pretty close to the perfect value, which I'm assuming to be like 10 volts right there. I mean, overall, I have to say the voltage on this keyboard is really, really solid. So I'm very happy with that. Okay, so the next thing that needs to happen is I have to use an oscilloscope for the next measurement. And what they want me to do is to put like the ground of the oscilloscope on that test point where I got like that roughly like 10 volts voltage, and then press C1, and that will result in this sawtooth wave that I can then use to verify that the basic level is the same across all of the 6 voices. And the way you test for that is that there's 6 other test points that correspond to each one of the voices over here. Once again, sorry I can't really show you, there's just like little rings coming off the circuit board, but they're like clearly labeled. So if I go here and go to the first test point, I can see that the waves are just a little bit below the ground line right there. So let me just kind of go to the next one, and they are indeed on the same spot. And I'm checking like the third voice, once again in a similar voltage range, same thing here. So I mean, they're all very consistent. I mean, I'm rushing through this obviously, but yeah, come on, connect. There you go. Voice 5, and last but not least, voice number 6. Yeah, and they're all good. Okay, I'm gonna go handheld real quick so I can show you a little bit what I'm doing. So as I said, like the test point for the ground is right there, and then over here, if you can see, there's like these little yellow rings here, and those are like the various test points for like the 6 voices. So what Korg is saying that I need to do next is basically to find the voice that had the loudest peaks. And in my case, like they all had like identical peaks, so it doesn't really matter which probe point I use. And basically place the probe on that loudest peak voice. As I said, they were all identical, so I'm just using like voice 3 just to kind of have the probe of my oscilloscope a little bit out of the way from the little adjustments. So and now I have like some calibration to do. So, and I kind of messed around with like the knobs just to kind of start from scratch, just to make my life easier, right? So let's recalibrate it. So right now I have my oscilloscope set to the test point for voice number 3, and I have my ground set on this little test point 1 that they wanted me to put my oscilloscope ground on. So far so good, I hope so. I am hitting like the low C, and I have this sawtooth waveform, and what I've done is I place my cursor. You probably can't really tell, the screen is kind of small, but I place my cursor on the peak of this waveform, okay? So the very peak I marked, okay, this is where like the peak is for this voice. So now what Korg wants me to do is to play the highest note on the keyboard, which is C6. And I play C6, and all of a sudden like the keyboard switches to this highest pitch. I have to change my scan timing here so I can see a little bit better what I'm doing. But if I zoom in, then you can see that I'm getting very much like the same trademark sawtooth waves. And what Korg says is like the peak for this guy should be the same as the peak for like the lowest. And it is, because as I said, I already ran the calibration. So if it isn't, then there are 3 trims. Well, there's 4. I'll get to the 4th in just a second. But there are like 3 trim pots. One is marked high, one is marked middle, and one is marked low. And what you want to do is you want to adjust, in this case like the high one, to lower the value so that the peak will fall on the same peak as the lowest note, which is right here, okay? And you want to repeat the same procedure back and forth, and check also A3, which is this middle adjustment. I don't know why they didn't do like high, middle, and low, but instead it's high, low, and middle. And basically from time to time you want to just kind of adjust all of these little trim pots so that you get like ideally a very consistent peak, you know, right at the point for all 3 ranges of the keyboard. I mean, it doesn't have to be like super crazy spot on, but I mean, as close as you can get it, that should give you, you know, like even pitch across all 5 octaves. Hopefully this is not something that you'll ever need to worry about, but nonetheless, it's good to know that that's basically the idea here for this calibration. If you're not confused enough, there is a 4th trim. As I said, there's the high, the middle, and the low, and there's a 4th one called bend. And what this guy is there for is so that you put like the pitch bend range at maximum on the front panel, and then you shift this, you know, the joystick to the maximum value, and then you do the same test, and you want to make sure once again that the peaks are all falling where they're supposed to be. And once again, you can adjust the bend trim to get those pitch bend peaks to be in range as the high, middle, and low keys on the keyboard. And when you do that, you should be good to go. As I said, hopefully this is not something that you ever have to deal with, but in case you're getting like this kind of weird warbly notes across the keyboard, this is how you fix it. Okay, so as you just heard, everything's finally playing correctly across all 5 octaves. I'm very, very happy with this repair. So the next thing I want to do before I call this completely done is just kind of check the master tuning, just in case something shifted during the recalibration process. So what I'm going to do is place my tuning knob, the master tune, exactly down the middle as much as possible. And I'm just using like the first program, number 11. And before I actually check my little chromatic tuner that I have on my laptop, I want to make sure that any detuning or other LFO weirdness is disabled. So I'm just going to go into the parameter edit. So there's a detune on number 24. So I'm just going to put this down to 1, I guess is the lowest value. There is, let's see, is there any pulse width modulation? No. And then on the LFO activity, like 61, get that off, 62, take that off, 63, and 64. It's already off. Okay, great. So now I have as pure of a tone as possible. So I'm just going to hit like A, and it's spot on. I'm just gonna hit the lower A. Yeah, I mean, the tuner is having a bit of a hard time with like some of these pitches. But the most important thing is that I want to make sure that overall across the keyboard, the pitch is as close to center as possible. And then of course, you know, this being like an analog synth of a certain age, some master tuning adjustment will be necessary from time to time. But overall, the you know, like the calibration worked really well, and the pitch appears to be spot on across the keyboard. If it wasn't, you can open up the panel, and if you look carefully right here, there's a little hole. Hopefully you can see it, and hopefully it's in focus. And you can kind of stick a little flathead screwdriver through there and kind of gently turn to adjust the master tuning. And there's a similar couple of knobs down there. One is for like the high pitch bend, and one is for the low pitch bend. And you can adjust those as well. But in my case, everything is perfect, so I'm just gonna leave it alone. I received a new battery in the mail, which I soldered in and installed. I opted to still keep it off of the circuit board and off to the side. I'm using like some little rubbery double sticky tape to hold it in place. I think it's much safer. I mean, it shouldn't leak. It's, you know, modern technology. It's kind of like much better designed than these old crappy guys. But I still think, why not? Just the extra precautions to kind of keep it off the circuit board, just because these guys are relatively inexpensive to replace. Circuit board, not so much. One of the things that I was kind of surprised by is just like how much smaller it is. I don't know if you can tell, but like this guy's about like 4 times the size of that. But they hold the same charge, 3.6 volts, and it's fully rechargeable, so I don't have to do any like weird hacky kind of ways to block the voltage from flowing into like the other flat type battery. I think this is a much better solution. They're still available. You can buy them on you know, Amazon and other electronic stores, and I just think it's much better idea. So if you have an opportunity to use the right component, use the right component by all means. I just wanted to recap a little bit everything that was done to bring this Poly 61 back in full working order. So when I first got it in, there was like a lot of like weird off-pitch warbly notes throughout the 5 octave range that definitely sounded wrong. And in addition to that, like a couple of the keys on the keyboard just weren't triggering properly. So the first thing I did is open it up, checked out the voltage. The power supply is outputting really great voltages. I debated whether it needs a recap, but ultimately the capacitors look fine, the voltages look fine, so this time I opted not to recap the power supply. I don't think it's necessary. Next, I took a look at the internal battery, which had started leaking and can damage the CPU circuit board. So I promptly removed it and replaced it with a brand new rechargeable battery. And I also moved the battery off to the side so that even if it does leak in the future, it's not going to create any issues with the main CPU circuit board. Next, what I did is I took a look underneath the 477 circuit board that's like underneath these knobs right here, and I spotted quite a number of leaky capacitors, so I replaced all of those. And while I knew that this wasn't going to fix the underlying problem with the synth, I think it's just good preventive maintenance nonetheless. So the next thing that I did is remove the keyboard and get to the sensor board underneath and just kind of clean all the sensors out, just to make sure that all the keys are now working as well as they should. And last but not least, it was time to tackle the main issue, this kind of weird off-pitch, warbly, oddball sounds that were happening on certain notes on the keyboard. And that was like a twofold issue. One was that a couple of the 4051 multiplexer chips had failed, so I replaced those, and then I recalibrated according to the Korg instructions the entire synth, and now everything sounds great. So I'm very happy with this repair, and hopefully the owner of this Poly 61 will be too. Unfortunately, I'm not going to be able to do a jam video on the Poly 61 because I have to bring it back to the guy that owns the synth. This is not my synth, unfortunately. But there are plenty of videos that you can check out on YouTube if you want to hear what the Korg Poly 61 sounds like. Alright, we did it! This Poly 61 is back to its full glory. I think it sounds great across all 5 octaves, and I think it's a great sounding synth, and I'm sure the owner is going to be thrilled to get it back in full working condition. So thank you so much for watching this episode of Case Labs, and I'll see you on the next one.